Hello guys, Assalamu alaikum. My name is Sayyid Mansoor Shah and here I am at lecture number 6, which is Bitwise Operator. Okay, so I am taking to identifier which give the identity of A. So A is equal to 60 and B is equal to 13. Okay, now I am taking one more identity C which give the result of A and operator B. Okay, now C out C, and here I'm run it. Okay, whenever I run it, so it gave me a 12. What? It gave me a 12. Now, how it gave me a 12? Let's go toward the calculators, and here I'm patting a 60. So let's check it out. What is the binary number of a 60? Okay, this is the 60 binary number. Here I'm pasting. Okay, if you want that you just convert decimal number to a binary number with your own self without any use of calculator. So here see this 60 divided by 2. 60 means LCM. Okay, so 2 3s are 6, 3 and 0. Okay, now see this. What is the remainder? Remainder is 0 over there. And now again 2 1s are 2 and 2 5s are 10. 2 5s are 10. What is 30? What 30 become a 15? See this, 2 divided by 30, 2 divided by 30. So what? 2 1s are 2. So what remain? 1 and 0. 2 5s are 10. 2 5s are 10. So are there 2 5s are 10. So what is the remainder? The remainder is 0 again. The remainder is 0 again. Now let's go ahead. Now 2 7s are 14. 2 7s are 14. So here what we got? We got one remainder. Okay. Now 2 3s are 6. Remainder 1 again. So here 1. And the last 2 1s are 2. So what is the remainder? 1. Now write it from like this type. Okay, from like this. What I mean? First we write 1, 1, then 1, then again 1, then 1, then 0, 0. So see this. These both are equal? Yep, these both are equal. Now let's convert 13 number to a decimal. Okay, and to a binary. Sorry. So I got 0 0 1 0. Okay, here as we see these both are not equal. So how it is? 1 2 3 4 5 6. So let's make it a pair, a two pair of 4 digits. Okay, 2 pairs of 4 digits. So how we can make it? We can make it like that. 0 0, it's become 8. Now space in between them, so it's become a two group of 4 digits. Here I'm passing 0 0 0 0. Okay, like this. So now let's check it out. We use our AND operator. So if both are same, then we put its one result. So like see this 0 1. So what? 0 1. These both are not same. One is 0 and other is 1. So this is 0 and 0 0 is 0 and 1 1 is 1 and then again 1 1 1. 1 0 is 0, 1 0 is 0, 0 0 0 0 0 0. Now let's check it out on a compiler. Now on a calculator. That what is the result? Swap it. Okay. Now we have 1 0 0 0 4 0 maybe. Yep, 4 0 and then 2 1 and then 0 0. Okay, convert. So see this 12. See this 12. Okay, so what is our answer as well? If I run it again, our answer is 12. Our answer is 12. Okay guys. Okay, this is an AND operator. Now let's move toward the OR operators. Let's move toward the OR operator. Here from int I just take OR. Run it. It says 61. So how it says 61? Now let's check it out. Again, move toward the whiteboard. So here, first we use an AND operator. Now we have OR operator. In OR operator, if one thing is means if 1 is 1, so it is 1. Okay, so it is 1, and if both are 1, so of course it is also 1. So let's check it out. 0 1 1, 0 0 0, 1 1 is 1, 1 1 again is 1, and 1 0 is 1, 1 0 is 1, and these both are 0 0. So what we have, 0 0, 4 1, and 0 1. Let's check it out. Here I'm just what we have, 2 0, then 4 1 1, and then 0 1. Let's convert it, 61. So see this. Okay guys, now let's go toward one more. We have XOR. So what XOR do? Let's first compile it. F11. It says 59. What it says? It says 59. So how we got 59? Let's go toward the whiteboard. Now see this, where we have 1 1 1 1, and we just shift into 0 0, and this 1 1, and then 0 0, maybe like that. Let's check it out. 0 0 2 2 3 0 1. Oh, double 1, sorry. Okay, G. 0 0 double 1. Let's check again. Then 3 0, and then 1. Convert. So see this. 49. So how we got this 49? See this. And this is 0. This is inverse of it. Like 0 1 is 1, but 0 0 is 0. But we have a same, like, but if we have a same, so we just change it to a 0. But if we have a different, like 1 0, so we just print it as a 1 and 1. We just put it as a 1. Okay, this is XOR. Okay, let's go toward one more. What is not equal? Okay, this is we use from a single. Like I'm just searching about this symbol. If I found over there on a keyboard, yeah, over there. Okay, now let's run it. So it says -61. How it says -61? So see this. If I take this thing only, means A. So 0 0 1 1 1 1 0 0. What is the inverse of it? Its inverse of it is 1 0 instead of 0 1, and 0 0 is equal to 0 0 1 1, and 0 0, then again 0 0, and then again 1 1. So let's check it out. 1 1, and then 0 0, again 0 0, like this. Yeah, 4 0, and then again 1 1. Now convert it. It says 195. Okay, so maybe it's not like that. So let's check it out again. Bitwise. Okay, let's leave it. I will discuss about it in a next video. Okay, so now let's tag this shift. Shift, this means shift by 2. I'm just here tag a shift by 2. Okay, now let's run it. So what we have 240. So how we got 240? We says shift it toward 2 bits. What shift toward 2 bits means? See this. This 1 1 will shift toward over there. Means that this 2 will go, this 2 1 will go over there, and this 2 1 will go over here instead of this 2, and this 0 0 will take this position of 2 1 1, like 1 1 1, and again 1, and then 4 0 0 0 and 0. Okay. Now let's check it out. So we have first 4 1 1 1 and then 0 0 0 and again 1 0. 4 0 4 1 converted, so 2 4 0. Okay. Now let's go one more. We have this, which means shift bit to the right. Shift bit to the right. Like, it simply means that, see this, now for a shift left, we have that this two will shift over there and this become over there. Okay, so now in this case this double one will shift over there and this double one will shift over there and this 0 0 will go over there. Okay, so this be like that, 0 0 0 0 and again 1 1 1 and 1. Okay guys, so now let's check it out. Just erase this one and put it over there, 1 1 1. Okay, converted, it says 15. Now let's compile it. As our answer is 15 or not. If I compile it, it gave me a 15. It gave me what? It gave me 15.